Hello and welcome back. Today I have really something nice, and it is yeah, it's old. It's from HP, and it's a frequency counter, and on top of that it had Nixies, and it's this one. It's the HP 5245, but it's the M version. And I will tell you a little bit about the difference between the M and the L versions. You probably have seen it if you are watching other electronic channels. It appeared on the signal path, and that one was really looking very nice. This one is a little bit older. I found it in Italy on eBay, and well, let's have a closer look. So we have it on the bench, and it is quite big. It's actually huge. I think it's about 20 kilos, and you can see it's quite deep. The exact measurements we can watch later. It is from late 60s, I think 67, and yeah, it is powered with those power cables from HP. Those, I think it's the PH163. It's those with 3 holes. These cables are nowadays very rare. And if you want to buy these cables, you probably pay between 20 and 30 euros. It's really crazy. And but I have one, and I use them for, I think I have 3 old devices from HP that use this plug, but I only have one cable. And somehow I cannot convince myself to buy a $30 cable. So I'll be using this one. So here it is. Let's have a closer look. As you can see, it is a little bit old. This is broken. This is a plug-in module. It is the 5253B, and it's a frequency converter. It is different from a prescaler because it is kind of a frequency mixer, while the prescaler is a sort of a divider. I will come back on this later, but you have several modules on this one. I only have one, this one. Well, as I said, it's the M version. You can see it here. It's the 5245M, and there are a few differences between the M version and the L version. The L version is standard with, by default, it has 6 Nixies. And as an option, I think the option 01, you can have a 7-digit or an 8-digit. And this one comes by default with 8 digits. And there is a reason also for that, because while the L version has a 1 megahertz, it does have a crystal oscillator, 1 megahertz, but it is just in a very simple heated insulation. While this one has a big oven, 5 megahertz. And it's I think it's 10 times more stable than the L version. But these frequency counters by now are very old, so probably none of the oscillators will still work proper. But yeah, just have a look. We have here the sensitivity. You can put the 10 volts, 1 volt point, so 100 millivolts sensitivity, and the on-off button, and your sample rate, DC input, so, and an AC input. Here you have your gate. You can set all the time base. You can set the frequency. You can put it to manual, that you can just use the button. There is a remote control in the back. And you can even mention time periods instead of frequency. And I think you can even switch it to the plug-in. Now that is this one. If I set it here to the plug-in, I'm not using this input, but I'm using this input. And here is a frequency mixer from 50 to 500 megahertz. And this one counts up to 50 officially, but if you try, you probably can find out it will be around almost 70 megahertz. Well, here we have our famous power plug. As you can see, it's not a standard, it is set to 230. I'm gonna put it down again. Here we have some auxiliary ports. I don't know what it is for. Here we have the storage. You can switch that on and off, and that has to do with during the counter, if you can see it count. or it will count and hold. And if you wanted to count and hold and only update after the count has been done, you set the storage to on, and if you like to see it count, then you set the to off. We can play a little bit with that. And this is also an extra on the M version, and that is it has a scaler, while the L version you only can input 1 megahertz. Here you can put also 10. Now it even seems that if you set it to external, you can enter here input 5 or 10. It doesn't matter, it will figure out himself. And with all the old counters it usually was 5, 2 or 1. And I think with the Alpha version, I think it was even only 1 megahertz. And now you could use the scaler even. So when I input here 10 megahertz, I can even use the scaler to output to another device. If I need 1 megahertz and I only have a 10 megahertz external reference, I can just use this scaler here to output my 1, and that one would be exactly synced to the 10 here. So that is kind of cool. So let's just have a look on the inside. I really wonder what we will see. It is just a screw with a fast click, so it's just click, and then we can open it. It has those foam tape thingies. This will always degenerate. It will be completely gone and it will end up as dust inside. I've seen it in a lot of counters, and the purpose of this is that it holds the PCBs down. But after 50 years this stuff is completely gone. And well, I think the former owner already cleaned it a little bit, but let's have a look at the circuit boards. So the PCBs, here we have the BCD and the Nixie drivers, 1, 2, 3, 4, 5, 6, 7, 8 digits here. And if you can see, these are just all transistors. So let me just get one out. You see, there is no integrated circuit, just transistors. And our big Nixie digits. I have been told that inside here is, yeah, well, it's not really an optocoupler, it's actually like a little neon light with a photodiode, and they are inside. And this is how the high voltage is coupled to the BCD drivers here. All the PCBs are just in these edge connectors. Here we have the input circuit right here, and well, here are all the digits, so we can take them out one by one when we want to clean them. And I think only the first digits is different, so these are all the same. Well, this is where the plug-in is housed, but if you compare how it was, just the empty housing without plugins was $2,800, so almost $3,000 in that time. So with current money that would probably be around 6 to have an idea. The mixer that we have here, 50 to 500, is around $500, and I do see there were already pre-scalers in that time, but they were like 850. So this was really a very professional device in that time. And then we have the oven oscillator, that is this one, and you can see really the difference because I will show you a picture of the L version. Let's have a closer look at the oscillator here in the back. As you can see, this one is a lot bigger than the other one. Here we have a power supply. Here are the outputs and all the voltages that we need. And this temperature is kept around 70 degrees, I see. So quite hot. So it will draw some power if we connect it. And the temperature is always kept when the power is connected. So even when it's switched off, it will keep it to temperature. So it doesn't need to heat up too long. Well, that all sounds very good. It is this high stability crystal oscillator oven, but as I said already, this one is 50 years old, and the first thing that usually breaks, these the components are like rock solid, but because the oven is always switched on, usually the problems start there. And you mostly will find little modifications that people already put in another oscillator, or they did some other tricks. And I know that they also did something to this one. I knew that when I bought it, but I still thought it was an interesting counter. And I can show you that on the other side. So we have the upside down. Let's open. Same quick locks. All the feet are missing. Well, that's usually normal. Because of its age, it just loses. So let's have a better look. Okay, looking from the front again, we put it upside down. And look how all these switches are wired. This is all manual work. So many little wires and soldering. And again, mostly just standard transistors. Same here. This is the bottom of all those edge connections. Yes, and now here in the back we can clearly see there is a modification done. I see two little ICs there, and I think even underneath there a little standard crystal. So I think they tried to build here their own little oscillator and they divided. So there was already a problem with this oscillator here. Oh, here is that little modification, and let me try to zoom in a bit more. Here it is, and it seems like a standard crystal right there. No oven, no nothing. So probably the real oscillator didn't work as it should, and yeah, they need something to make it oscillate and probably they divide later. So let me try to make a picture of these components. And the output is the white cable here, goes to the pin 1 right there, and here hidden away is the old connection. Still, it seems like a coax cable. If we follow the cable, it is this one here, and it just goes to the bottom to the original oscillator. So they just disconnected the original oscillator and connected here the output of this oscillator. So, well, first of all, I like to see what comes out of the output of the old oscillator. If it's still powered, we can just measure that cable there, and let's see if we can measure the output of this one. But this needs to be replaced for something proper. Well, okay, that is one way of doing it. They have this crystal of 20 megahertz, and then they divide it down to 5 megahertz. One goes to the edge connector, one cable, the other cable going to the BNC plug in the back. So you have your 5 megahertz output there. Yeah, nowadays you would maybe get an oscillator block like this, or if you want to do a little bit better, you can even go for this Vectron, or you even have the CTIs that come completely. This is 10 megahertz, but then you just divide it down to 5. And or if you want to go completely crazy, you can find these old Trimbles with oven, and yeah, these you can also just adjust exactly to exact 10, and then you will need to divide that down. But probably this thing will be the most useful to run it. But first, and I will probably run it on external reference anyway, but let's see what it does. So according to the manual, the oven is already running when you just plug it in, and it doesn't need to be switched on for that. So I have in my little power meter and I'm just going to see. So, well, clearly, even though the oscillator doesn't work anymore, they left the oven still connected. And as you can see, it's taking like 55 watts. I forgot to just disconnect the heater. I think that is just two pins in the bottom, to be honest. You need to be careful with that because I think it is because it's fast heating. There could be like 100 volts on it. So okay, it's plugged in now for about 2 minutes, and the power is already down to 12 watts. So that means that the oven is hot. And why is that so fast? Well, I told you. You need to be careful because in the bottom of the oven, and I think you can see there, if I measure 150 volts on the heating element of the oven. So this one could have been disconnected and you save the power if you're not using the heater. So I can disconnect that if I add the other oscillator, if I will. Okay, let's just power it on. We can have a look here at the power also. Big ventilator running. Oof, a lot of noise. And we do see 1, 2, 3, 4, 5, 6, 7, 8 digits. That is good. And 100 watts, and it will stays more or less good. Let's try an input 10 volts, highest first. 1 second. Not the. Let's put the frequency. Let's put in 10 megahertz and let's see. Okay, let's put 10 megahertz in the input, the AC, and I just take it from one of my distribution amplifiers. And oh, it's not doing anything, but I think I might have left my switch to external reference, so I will just switch it to the internal first. Yes, it is. Here we have the 10 megahertz, but the oscillator is off, so will we not have exactly 10. And we can play also with the storage switch, because now the storage switch is on, and you can clearly see that it is, while it is counting, it keeps the last result in memory, and it will show you that last result until it's done with counting, and then it does an update, as you can see here. But what happens if you put the memory switch off? Where is my memory switch? I need to be careful because that ventilator is metal, so I will just cut my finger. Yeah, this is with the memory function switched off, and then you can actually see it counting, which is also very cool. And if I put it then to 10 seconds, it will take a very long time. But it reads a lot better with the memory on. Then it will just do the update. So that's the storage switch. Well, so why, if it's all working, is it not exactly 10? Well, this is because the internal oscillator is too slow, because we count too much. So that means the period we are counting is too long, and that's why we count more than we have. So the oscillator is too slow. Let me connect the output, the 5 MHz output, to my frequency counter right here, and let's see how much it is off. Okay, I connected the output of the frequency counter to my other frequency counter, and if you can see here in the back, it is clearly lower than 5 MHz, and that is why we count too much. So I can try to adjust, but I cannot do that on the oscillator itself, not the original oscillator, so I will have to do that on that weird modification that I made. Well, the trim pot is in the bottom, so to be able to reach it, I need to turn it on its side. But turning it on its side also means that the gravity on the crystal will have to change. So I, I need to adjust it in the way where it is now. And let me show you. I'm not sure if you can see this counter in the back here, but you can see this value. So if the oscillator changes, this value will also change. So if I put it on its side now, and it's set to 20, it is not changing at all. Great test. Well, it goes down a little bit. So that also means I can just adjust it like this. So I need to adjust it right there. And we're gonna have an eye on the frequency counter there. So I will be adjusting the oscillator. So this one needs to go closer to 5. And then this one will of course become 10 because that's what we're measuring. So let me try to do that. This is as close as I can get it now with this simple oscillator thingy that they built inside. So let me just turn it back on its good side. Okay, well, we are still a little bit off, and it changed, of course. Now we have it horizontal again, but this is not the oscillator I like to use anyway. So if I do a replacement, I will do this with this radial Vectron or this PTI thingies. Let's see, because we do now 10 megahertz. Can we do 20? Yes, it does. 30, 40, 50. It should be able to do 50 megahertz, it says. And this one is also connected to external reference, so that's why it is still a little bit off. Let's go to 60. Can it do 60? It can. Can it do 70? It can. And it's sort of a stable reading still. Can it go a lot higher than 70? Because it is spec'd for 50. No, it doesn't do 80. 71. 2, 3. That's it. Seven to 500. That is sort of the limit. Okay, now I wonder what happens if we connect it to external reference. And in this, the M version is easy because you can just take 5 and 10. So I can just use my standard 10 that I have here. So I'm going to connect that, and then we should have an exact reading and sometimes exact on one digit because sometimes it just misses one. So let's just see. Okay, we are now on the internal reference, and now we switch it over to external, just the normal 10 megahertz. Puff, spot on. Okay, I've taken the module out, and then I noticed there's a screw in the back right here. And in this screw in the back, it says oscillator frequency adjust fine. And then I'm looking here. And I see here some kind of pot, and I thought it was a switch to check if the plug-in is plugged in or not. But it turns out it is some kind of a pot for the fine adjust of the oscillator. And then I wonder, maybe the oscillator is working, and they thought that the oscillator was just not good. But it could also be that they tried the screw in the back and it didn't work, and it turned out we need to use the screw here in the front. So now I like to see, is the oscillator even broken? So let me see if I can just measure the oscillator. I will first do the modification one. That should be here. And you can see that one is below. And if I take the other one, that is the loose wire that I disconnected, and that oscillator is also running, and it is not even that bad. So then I wonder, maybe it only needs to be adjusted, and why then they did their own modification? That didn't make sense, because this one is offenized and it should be super good oscillator. So now I'm a little bit confused what I try to do. So the oscillator is still good on frequency, but that was not the problem. I notice now, because it seems pretty stable, and it was very easy to adjust to exactly 5 megahertz. But the problem is something is broken inside of the oven, because the level is much too low. Here I have a level now of almost 2 volts peak, and when I measure on the original oven, I only have like 100 millivolts peak, so it's really a factor of 10 that it is too low. So maybe I can try to fix that, or I just put another oscillator in, or I don't worry at all and I just connect it to the external reference. But that is probably why they built something else. Okay, then we have the plug-in. Well, the plug-in already seems that it is mechanical. There is a problem with it, because it is just stuck, and it is just stuck here, and it all works in a cavity oscillator here, and there are a lot of little threads and wheels and things, and they already say here, do not disassemble, because it will not work anymore. Well, already it doesn't work anymore. So maybe I can once find out what is with this plug-in, and maybe some of the wheels are dirty, or well, how does this mixer work? Well, it's more or less like any other mixer, only this works with an harmonic selector, and it is done in the cavity. So by enlarging the cavity, you can pick other harmonics. So they just put in 10 megahertz from the frequency counter itself. It goes up to this plug-in, and then with the selector you select which harmonic you want to pick, and then amplify, and then mix with your input signal. And if you mix those two together, then the difference will go out to, again, a frequency amplifier and a low pass filter, and that will go to your counter. So if you add here 450 and you mix here 400, then the result will be 50, and the 50 goes out, and in the counter you will see 50, and then you need to add the frequency of the one that you selected here. Okay, 3 guesses what I did. It was only mechanical, so I put some oil on the big threads here in the middle, and here you see a lot of the other wheels. I cleaned it all, because when it was stuck I could still move this. So if I move this, it is here pushing on this thread here, but when it was stuck I could still move this. So I knew, okay, the inside of the cavity is still good, because I can still move this, and the same for this one. So then it really needed to be something mechanical, so I put some oil on the big wheels there, on the long thread here, and now it is super smooth. Now it's a pity I'm missing this, because then you are a lot faster. But as you can see, it is super smooth. 500. There we go. 250. So now my favorite part, the cleaning. And well, you can see it's 50 years old. It has scratches. Some of the buttons are broken. Well, and they are dirty. Well, the buttons are a little bit broken. I cannot really fix that, or I really need to have other buttons from another counter. But I don't have spare parts, but I do like that the Nixies can be a lot brighter, and I will zoom in because there are also a lot of scratches in the display. And I want to try to get that out again, and then the Nixies become all bright again. So some of the buttons are broken. Not much we can do about that. This is still good, but it is very dirty, and the display is scratched. And when it is scratched, you just don't see the Nixies that well. So I will try to do that also with my brush cleaner. I will try to get the windows out, and I will also clean the Nixies carefully. So I will need to take all the PCBs out. Then maybe I can take the window out, and then I polish that, put it back, and then it will look a lot better. So the cleaning is done. For the next project, we can have a look at why the original oscillator is perfectly on frequency, but the level is just too low, and that's why they made another oscillator. That one I adjusted as good as I can, but it is just a terrible oscillator. So, or I will do one of those factors in there, and then I do a divider up to 5 megahertz. Well, we can have a look why this oscillator, the level is so low, and maybe we can just amplify that. And then we have it as original as possible. The cleaning worked very fine. Also the frequency mixer is running free now. So that is perfect. Only it doesn't work. So maybe also I can later look at that. But for now it's running on external reference, and you can see it's spot on. And let's have a closer look because the Nixies are super bright again. So here it is. Let's have a closer look. The Nixies are super bright. You can even see the reflections. That brush cleaner really makes the display look a lot better. And you take all the little scratches out, and of course the 50-year-old dust, and then the display is super bright, as you can see. And I think the cleaning did make it a lot better. Even all the text. Here, everything looks so much better. Even the plug-in module, because that one also looked very bad. And that is also a big improvement. But yeah, always the display stands out. So it did turn out a lot better than I expected, and I'm really happy with the result. And look at the Nixies, they smile at you. Thank you for watching, and hope to see you next time.